same sentence all the time, right? But what does that actually mean? What's really keeping it safe? Let's go behind the curtain and see how this digital fortress is built.
All right, before we dive in, just a quick disclaimer. This explainer here on blocks, bonds, funds is for educational and informational purposes only. It is not and should not be taken as financial or investment advice. Okay, everyone says blockchain is secure. But what happens if someone actually tries to break it?
What if they tried to, I don't know, rewrite history itself?
So let's cut through all the noise. What actually makes blockchain secure?
To really get a handle on blockchain security, we need to rewind a bit and look at the problem it was built to solve. And honestly, it all boils down to one simple word: trust.
Think about it. In most systems we use today, you're forced to trust a central authority, like a bank. All the data, all the control, it flows through them. But that creates a huge vulnerability, a single point of failure. If that one central server gets hacked, well, everything is at risk. Blockchain completely flips that script. It throws out the central server and replaces it with a peer-to-peer network. Here, control is spread out across everyone who participates. There's no one single place to attack.
So how does this distributed trust actually work? Well, it's built on a foundation of pure mathematics. This is what we can call the cryptographic shield. It's the very first line of defense.
Okay, so it all kicks off with something called a cryptographic hash function. Now, the easiest way to think about this is like a digital fingerprint machine. It can take any input data, I'm talking a single word or an entire novel, and it spits out a unique, fixed-length string of characters. This is its fingerprint. And here's the really important part. It's a one-way street. You can't take that fingerprint and work backward to figure out the original data. It's impossible.
Now, this is where it gets really clever. Each block of transactions gets its own unique hash, its own fingerprint. But here's the kicker. It also includes the hash of the block that came right before it. What this does is create a cryptographic chain linking every single block together all the way back to the very beginning.
And this little feature creates an absolutely incredible security layer. Imagine a hacker tries to change just one tiny detail in an old block. That action would completely change that block's hash. But wait, since that original hash is recorded in the next block, that next block is now invalid. Its hash changes too, and so on, all the way down the line. It creates a domino effect. The entire chain breaks from that point forward, and the network would immediately see it and reject the fake version. This is what makes the ledger, well, basically tamper-proof.
Okay, so the data is locked down and tamper-proof. But how do we prove who actually owns what? Well, that's where digital signatures come in. Every single user gets a pair of cryptographic keys. A private key, which you keep totally secret, like your most important password, and a public key, which you can share with anyone. To send a transaction, you sign it using your private key. Then anyone else on the network can use your public key to check that signature. It proves two things. One, that it really came from you, and two, that it hasn't been messed with. It's perfect proof of ownership, and you never have to reveal your secret.
All right, so we've got these incredible cryptographic locks protecting all the data. But that brings up a new question. Who actually gets to add new blocks to the chain? Well, that power doesn't belong to any one person. It comes down to the power of the network itself. We're talking about strength in numbers.
See, before a new block can be added, the entire network has to agree that it's valid. This whole process is called consensus. When you send a transaction, it gets broadcast out to thousands and thousands of computers on the network. We call these nodes, and all these nodes work together to check the transactions and come to an agreement on which block is the next legitimate one to add. The key here is that no single person or group gets to make that decision alone. Now, there are a couple of popular ways networks reach this agreement. You've probably heard of them: proof of work and proof of stake. With proof of work, which is what Bitcoin uses, miners use massive amounts of computing power to compete to solve a really complex math puzzle. With proof of stake, validators lock up their own crypto as collateral, kind of like a security deposit. If they try to cheat the system, poof, they lose their staked coins. So in both cases, the system is designed to make cheating a really bad financial decision. It's just way too expensive to even try.
And this brings us right back to that key idea of decentralization. Because the official record, the ledger, is copied and spread across thousands of nodes all over the world, there's no central server for a hacker to target. I mean, to successfully attack a big network, you'd have to control more than half, 51% of its entire power, all at the same time. We're talking either computing power or staked crypto. For a massive network like Bitcoin, pulling that off is, well, it's considered pretty much impossible.
So, the cryptographic fortress seems unbreakable, right?
The decentralized army of nodes seems unbeatable. So where's the weak spot? Where do things go wrong? Well, as it turns out, it usually comes down to us, the human factor.
Let's look at a famous example. Back in 2016, a project called the DAO was hacked. An attacker found a bug in its code and managed to drain about $50 million worth of crypto. But here is the critical detail that almost everyone misses. The hacker didn't break the Ethereum blockchain. Not at all.
Stuart Madnick from MIT Sloan said it perfectly. He said, blockchain itself might be secure, but the use of the blockchain is where all of these weaknesses come through. The problem wasn't the fortress itself, it was a poorly built application sitting on top of the fortress walls.
And this difference is absolutely crucial to understand. The core blockchain protocols, like the one Bitcoin runs on, are incredibly strong and have been tested for years. But the apps, the smart contracts, the exchanges that are built on top of the blockchain, well, they're only as secure as the code they're written with. And that's where you find the bugs, the loopholes, and the human errors that create real vulnerabilities.
And when it comes to your security, on a personal level, it really all boils down to one thing: your private key. When you own crypto, what you really own is that secret key. If you lose it or if someone steals it, your funds are just gone. Forever. The blockchain can't help you get it back because as far as the math is concerned, whoever has the key is the owner. Period.
Okay, so let's zoom out. When we put all these pieces together, what does this new model for security actually mean for us?
Look, blockchain technology is, by its very design, incredibly secure. You've got these layers, cryptography, consensus, decentralization, that create a system that's way more resilient than pretty much anything that came before it. But, and this is a big but, it's not magic, and it is certainly not immune to bad code or simple human mistakes.
At the end of the day, what this technology offers is a completely different way to think about trust. It's a fundamental shift. So the real question it forces us to ask is this: who do you want to trust? A central institution with all its vulnerabilities, or the distributed, transparent, and unchangeable logic of the code itself?